We're back once again with the Renegade Master. No, with Eagle. So I did this board, a couple of days ago? It was on, I don't know what day is it. It was Tuesday. So I did it Monday night. Did I? Is that right? No, Sunday night. I streamed on Sunday night. And the idea was to create an LED clock. Now, I got pretty far with it. It's pretty complicated. There's a lot of wires going on. So what I've done is finished off the routing of this board. There is a little bit of an issue here. I don't know whether you can see it. If I, what is that window there? Oh, there we go. If I do the rat's nest tool, you'll see I've got an issue with some ground planes there. So some of the grounds aren't connected, which is an issue. So if I just click on one of them, let's find the unrouting tool. You'll see that this ground needs to be connected to this ground here. And unfortunately, there doesn't seem to be a way of doing that. It's difficult. So I have to find a way of connecting this bottom plane ground, which is all of this area here and there, with the top layer ground, which is here. So I'm not quite sure how to do that at the moment. But there are other issues with this board. So while it does look like it's, let's just, where are my ground planes? There's one. And there's another one. So while it does look like it is relatively rooted, an awful lot of wires, more than I've ever used, I think. While it does look like it's pretty much there, I forgot some components. So if I jump into the schematic view, you can see here that there's a problem with this microcontroller. I don't know if any of you watching can figure out what that problem is just by looking. But the issue is I haven't put a crystal on, so it would have to run at its internal oscillator frequency, which would be 8 megahertz. And I don't really want it to do that. The other problem is I haven't broken out the programming pins onto any pins that I can access easily, which means I can't actually program this. And because it's not one of the DIP packages, I can't just take it off and plug it into an Arduino board or do it on a breadboard first. It's in this AU package, so it would be very difficult to program once it's soldered onto the board, let alone reprogramming later. I could do it once relatively easily, but reprogramming it later would be difficult. So I've scrapped this board and redone it. Also, I noticed another error in my schematic. So I'm using this chip here is for lithium ion cell charging. It's called the MAX1811, which is made by Maxim Integrated Circuits. And the charging thing here, so we've got the charge pin. That's not an output high, so it's actually a drain. So when it's charging, that becomes a drain. So this is around the wrong way. So the LED should be going into the charge thing, and R6 should be going to the USB or in. Unfortunately, I didn't realize that. Even though I've used this chip an awful lot, so I just sort of forgot. So I will sort that out. Hey Ash, use a single wire to connect the ground planes. Well, here's the problem. So I can show you on here if we go to the little rat's nest tool. So here's my ground plane problem. And if I just add in a wire, I can't see past the webcam. There we go. The drill, we're in view grid. Millis, okay. Drill, the minimum drill size I can use is 13. And we're going to be using a round drill. Oops. No, round. There we go. So if I just pop one there, that's next to the ground that's here. And I can jump off that. I want to get off that. And we'll name it as GND. But it's not going to solve my problem because that ground isn't connected here either. And so I need to find a ground area. So maybe here. But then I know there's no top layer ground here either. And there's no connection between there unless... Is that going around there? Maybe I can pop it there. Let's try that. I still can't see. The balloon camera's in the way. Let's try one just here, maybe. There we go. Name GND. Unfortunately not. So it doesn't work. I've tried a lot. Plus, I have to rearrange it anyway because I missed out some components. So we're not going to save this. We're going to get rid of that. And we're going to open up the one I've redone. So it's not finished yet, but it is closer. So on this one, let's just bring up these windows again. That's my face. And then I need that on there. There we go. So on this one, I've added in my crystal because I forgot. I've also broken out the programming pins, which are 10, 11, 12, and 13. And what else did I do? I think that's added, which is a resistor going to analog 0 from the battery so I can monitor the voltage. For no other reason really than I just fancy seeing it. And I might break out the TX and the RX on here. In fact, I probably need to. So I haven't done that yet. Actually, I probably should. Yeah, it does look like I needed to move some traces around. I couldn't use any thinner traces. That's the 6mm is the smallest trace that the PCBs.io company will be able to fabricate, or at least their fab house is the only, that's their limitation. I'm not sure about OSH Park, but I fancy using PCBs.io, so we're going to go with that. Let's have a look at the board view. So I reorganized everything. I gave myself a little bit more space, so I gave myself 3 more millimeters on the top and 4 millimeters over here. So I've made the board slightly bigger, but you can immediately see that this is the orientation of this TLC 5940 is a lot better. It means that I can jump down to these LEDs a lot easier. I've also moved the USB to where the, well, I've just moved it over this side where I had a bit more space. And I figured that I've got these transistors down here to drive the rows. So I thought, wouldn't it be easier rather than where they were before, which was in this space. And then I was just bringing some wires down, or traces down, to connect to the rows. Instead, I decided to connect them directly across, and it's become so much easier to do. Now, it does mean I have a bit of a power issue. All of my input power is coming from this area here, so I've had to take a trace all the way around the outside of the board, which isn't a terrible idea. It's essentially a bus wire that's going all the way around, which is fine. It means I can dart off to those grounds and the power lines, the battery line as well. So it's working quite well. There's still a lot of things to wire up on here. And for what I'm going to do, I'm probably going to jump to the bottom layer and come across here. I'm going to try and keep most of this chip on the top layer to make it a little easier. There's my crystal. It's freaking massive. I'm using this one just because that's what I have at the moment. I'm sure I can get hold of smaller crystals, but I know that this one will take, I think it's 33 nanofarad capacitors, or it might be, oh no, it's picofarad, sorry. Or it might be 22, I can't remember. So the Crystals mounted on the top side of the board, which might not be the best. Maybe it's better on the bottom, and then having the capacitors on the top, possibly. I'm not sure. And this is where I've got my pins to burn the bootloader. So it looks nicer. I certainly am happier with the placement of all of these resistors to drive the columns. So every time we drive a row, we're going to be potentially lighting one LED from each one of these. So they've got a resistor. All of this TLC 5940 will do alter the voltage. It uses PWM. So all I'm going to do today is start wiring this thing up a little bit more. There we go. So we're on 6mm traces with a drill of 13. And we want the round one. So that is the smallest the fab house can do. They can actually do smaller drill holes, but they guarantee that ones of 6mm will work. Now we can probably reorient this chip. This is, what is this? Is this a capacitor? I think it is. This is probably, no, it's a resistor. Where's that going? Oh, it's just a resistor to ground. Is that accurate? Apparently it is. I wonder why. I can't remember. I would have pulled that directly from the data sheet, I would have thought. So that's fine. So that can go there. There should be a capacitor somewhere. So I want C3. Is that another? What's this one? That's C4. Which doesn't want to go there. C4 is for the 748C595, which I already seem to have a capacitor over there somewhere. So this is where I wish I hadn't turned off those layers. I'm turning them back on. Even though it looks horrendous. Right, so resistor. I should be able to spot a capacitor if I just do the rat's nest tool. There's a capacitor. No, that's not a capacitor. That is, though. Why don't I use a resonator? They're small and have the capacitors built in. I don't know about resonators. That's not something I know about, unfortunately. Right, so we've got a resistor there, capacitor. Well, that was C4, wasn't it, I think? So C4, where the devil is C3? It's not one of these over here, is it? C1, C2. Oh, C3 is on that chip already, that's fine. Okay. That's all right. So I just need to move this one over. So this needs to come over by this 74HC595. And where is the power pin for that? Let's look at the schematic. So we've got oh Ash, I can't be learning commands. I don't even know where to type them. Is it in this section here? So it's on pin 16. So where's the top of this chip? 1, 2, 3, 4, 5, 6, 7, 8. So power is there. That's interesting. That definitely was C4, wasn't it? No. Oh, that's why then. I've just picked up a resistor that I needed over here, obviously. It's that, isn't it? That's C4, yeah. It's just on the reverse, so I got confused. And I can throw that on the top layer, I think. There is the tool I want. Let's see. Oh, do you know what? Let's put it on the bottom layer and we'll flip that round. I'm going to have to move this, sorry, because I can't see the blooming tools. There we go. Thomas, I always, not always, that's not true. I usually buy one from a PCB manufacturer, so because it's not very expensive to get, so I will generally do that. Let's bring that around here. Especially when they're small boards, but oftentimes I will rig things up on a breadboard, or I'll use a little bit of Vera board or something. I can go a bit closer, can't it? Actually, it can just come all the way down here. So yeah, sometimes I'll stick it on a bit of Vera board, or I'll do a breadboard prototype before I make these. But because I'm using SMD LEDs, I already know how to run a matrix. I don't need to worry about that. And I've done these individual components in other boards before, so I mostly know how to use them. There is one thing on here we need to change before I go any further. We need to get rid of that and that, and add that to in. And rename that as C, oh, that'll do charge. Connect those two up, and that's going to alter what's it's going to alter what's happening over here. Yeah, I know you can put, well, you should put a resistor over for loading purposes, but I've never found it all that necessary. So resonators have 3 pads, so it's got your crystal out 1 and 2 and ground. Okay, I'll take a look at them. But at the moment I've got these crystals and I've got the appropriate capacitors for them, so I am all right with that so far. Right, where am I going to bung this? Let's put that. Let's just leave it there. And that needs to come over here. That's a bit of a problem, isn't it? Well, there's a solution. Let's take that out and stick that on the bottom of the board. Oh, I didn't need to do that at all. Well, I certainly don't need, didn't need that via anyway. So that's okay. Do I want that on the top? I do kind of want it on the top layer, so we're going to have to do a couple of vias. That's not a problem though. Go back to 6. I prefer to approach pins of chips from the top, but I don't really think it matters. Not too much anyhow. And this is a very small signal. So I'm using some slightly larger traces from the battery to the max chip because it's going to be charging at a relatively high current. Doesn't really matter, but these traces will certainly handle what I need them to do. Whoa. Zoomed out there a little bit too much. Harry, does the PCB manufacturer solder all of the parts, or there another stream coming with a load of SMD soldering by you? They won't solder any of the parts for me. I will get the cheapest manufacturer possible, which at the moment is PCBs.io. That's the cheapest one I've found. So I will be doing them myself. But you can request someone to do it for you. Do you know, I think I'm going to need to use the ground layer here. So I'm going to have to move this out the way because I've got 3 traces going that way. Whoa, don't want to be doing that. So, oh, it's there. So I'm going to want to bring that onto the top layer, I think. Yeah. I can bring that onto the top layer. And spin it around. Perfect. It's going to take a while to solder this one together, I can feel it. These are 0603 LEDs. Yeah, 0603, so they are tiny, absolutely tiny. And I've never soldered one before. I'm just going to assume that it's going to be easy enough. Solder one side first, so you put a bit of solder on the pad, and then you'll get a pair of tweezers, plop your LED down, heat up that solder that's on the pad. You might want to use a bit of flux, and then that side will be soldered, and you can then heat it up to readjust it. And then you solder the other side and then give the other side again a little bit more solder because you won't flood the pad with solder when you're pushing that chip on. And then you have to do that. How many LEDs are here? I'm going to have to count. So we've got 4 by 16, which is 4 by 16, 40, 2 4s are 8, so another 16, 56. Honestly. My maths. I need to sort that out. Right. So let's get a few more of these soldered up. In fact, let's drop this part down a touch. It doesn't need to be there, and it's blocking off a tiny bit of ground there, which I might cover up in a bit. So let's bring this down here. I've got very small vias, so hopefully one's going to fit there. Let's see. I can use my design rule checker to see if there are any overlapping parts. There aren't. That seems to be fine. This white area here is sort of the keep out zone. So as long as that's not passing over a specific part, then you're fine. Let's see. What have we got left to do? So we've got this the DS3231, which is a real-time clock. I don't know if I need it, but I bought 5 of these chips, so I'm going to use it. The battery backup for that isn't going to be a coin cell. It's going to be the actual battery. So the battery backup can go up to 5.5 volts according to the datasheet. So I'm going to throw on a lithium ion battery. I've not got one here. But that's going to go, it's going to not only going to power the circuit, but it's also going to be the battery backup for this. So it's not really designed to be very portable or to go on for a very long time. I'm not doing this for any useful purpose other than to learn how to do stuff, to route really disgustingly complicated boards, or at least they are in my opinion. Certainly if you look at this this PCB layout in comparison to the last one I did, this one's cleaner. I've learnt a lot from it, and hopefully it will work better than the last one, which was just so complex with the number of wires. Now, so this is on the top layer. Where are we going with this? Over here. So we'll probably want to use the bottom layer, jump over to here, and then jump back into the top layer to go over this, this IC here. So if I just pull that up here, that should be sufficient. We'll turn that into a bottom layer, and then we'll come straight across and then up again, because that frickin' thing's on the bottom layer. Does it need to be on the bottom layer? Do you know, I don't think it does. Let's undo what we've just done. Control Z. Very happy about Control Z. That definitely doesn't need to be there. So we can just bring that up. Oh look, oh that's perfect. Okay. That R20 should be the battery monitor, I think. Now, I don't even know if no, it's not R20. What was that command? Show R20. Well, oh yeah, wow. Would you look at that? I actually paid attention there. I don't know if anyone noticed. So that's R20. So what is oh, it's a pull up for the SDA, I see. Doesn't really need to be all the way over there though, but I guess it's sort of out the way. That's fine. Okay. I'm just going to have a quick read of the chat. So I haven't written the software for this, which is why I'm breaking out the programming pins. And I haven't broken them all out. I need to get TX and RX out as well. This is just for burning the bootloader. So, do you know, I really wish there was a way, or I don't know if there is a tool. Maybe someone knows there is. I haven't really researched or anything like that to look for one. One where you just push it over the top of the pins. That would be very useful. So you could just program it in circuit. I guess then it would power the board, so you might not have the amount of current coming out of your programmer that you'd need, but I could provide separate power. I'm just zooming in and out there for no reason. So let's get these pins done. Why on earth would you be going to there? Oh, of course, it's a shared SDA. I forgot. So do I have another I2C device on here? I don't think I do. So it is for that chip there. So that is foolish to have it over here. So it's literally just for this one. And where is the other one? It's probably R22, isn't it? No, R19. Can I use that same command in here? I'm going to try it. I'm doing it in caps because you did it in caps. Look at that. There it is. Well, that is actually in a good enough position. So the other one needs to go down here too. Can it go in the same place? Do you know what? I think it could go here. Done. Okay, we'll do that. I don't know what these 2 pins are there for, but we're not using them, so this is fine. What? Oh yeah, that goes to that side. That looks reasonable. Oh, look at that. That is perfect. Now I just need to connect my SDA and SLC to these pins here, which I will do on the... Will I do it on the bottom or the top? I think I might bring the bottom down here. We can always use wires to jump over those. And yeah, this is going to work out, I think. Oh, look at that. Is that too close? No, it isn't. I've sort of ignored chat a little bit, sorry. Yeah, the pogo pins, that's what I was thinking of, but I don't know if that actually exists. Oops. Well, I suppose you'd have to have a different layout for each different type of chip you wanted to use. Now, I'm going to be cheeky here and swing it over here and hope that I can drop a wire just there. I think I can. Yeah, that looks fine to me. So that's my SDA and SCL. Now, what else have we got? We've got a few... This board thing jumps around a lot. Let's try to start with the furthest pin away. So when you see this, I know that I have to route the ones that are on the top here and over the top of this line here. So that one's coming to here, so I'm going to have to do some wires to jump around a little bit. But these ones go to the further pin over there. So actually, if I do this one first, I should be able to fit a wire just there. This looks like it's a heatsink pad just here on the TLC 5940, but I'm only running it at about 50% of its capacity, so I'm not overly worried. Let's drop down a little bit and go to here. I'm going to have to jump to the top layer of the board again. I have to be careful. We've got a ground pin there that I can't really get in the way of. Now, because I'm using the first pin here, I'm going to go above it and drop another wire so that I can come back on myself and connect, so that I'm not getting away with the ground, on the top layer here, so that I can jump straight across it if I need to. Now, look at that. Am I going to be able to fit another one in there? I think I might be able to fit one there. We'll find out shortly. We'll come up a little bit. I'm trying to give myself as much space as possible so that I can connect anything that needs to go around here, which, you know, I haven't got a switch to turn the thing on yet or turn it off. So I think that might end up being a bit of an issue. And I've only got about 20 minutes before I'm turning this off as well. Look at that. Look, I'm ruined. But am I? Because I can just go the other way, which is fine. Can I fit one there? Let's find out. I can. Whoa, mayday. Lost my board there. Now where am I going with this one? Okay, so we're going to drop another via here. And, oh no, mayday. I have to drop another one there. And another one there. And another one there. Just to jump over all of those lines there that I'm crossing. I do hate vias with a passion. I find, I don't know, it's not for any real reason. What's this one? This must be, oh yeah, it's one of the programming pins, isn't it? So let's drop the via there. And we'll be coming across here. So let's drop down a touch. I think it's going to cut off those grounds, isn't it? I don't think it matters. We'll just go. No, let's do it. Let's follow the pattern. I like the pattern. Well, sort of follow the pattern. Now, how are we going to get over there? Because I've got a ground, not ground, a bottom layer there. So let's come up to here and drop another line. There we go, that'll do. That feels a little bit messy. Oh, yeah, I'm not a big fan of the any of the routing tools. I find I get myself stuck in them. So if I use that one to tell me if it can fit through pins or whatever like that, for example, I don't think I'd ever do that. But you are right. I use the actual auto router to see whether a board is even possible sometimes. So this is power. So I need to find out where I'm getting that from. Oh, okay, so it's coming from the main bus there, which I could extend up here and then go straight across with it. I think that's what I'll do. And so to do that, all I'm going to do is just unroute a portion here and then bring this one up. Oh, I think that is a metal bottomed crystal. So I'll do that for now and then we'll just take away that and we'll do it again. There we go, that's sorted that. And now we've got two unconnected grounds here. So we can connect them with a via. Probably just here, I think. Let's see. No. So this is the ground plane here. So this red is the ground plane up here and to here. So none of that is connected to the other side, which is a problem. No, it's not. I can change that. That's fine. Let's undo what we've just done. it's fine like that. So what I want to do is take it from here. So let's bring that back up. There we go. Then the ground should stay connected. Oh, what? Oh, it's this, isn't it? Of course it is. Okay. That's fine. Move the Excel trace. Yeah, I think I should. I'll tell you what we're going to do. We're going to do this. No, because I need those pins there. All right. Can we just change that into a via there? There we go, that'll do. And then we need to bring power over. But this time we're going to take it from the top here rather than put it into that bottom one, which should keep our ground plane intact, I think. That actually was, I could have done that the whole time. I mean, it's destroyed this area here, but I'm not overly worried about that. And then we need to pop that back in. There we go. So what have we got left? We've got 2 connections over there, and we've got 1, 2, 3 connections here. So let's see where they go. So this one needs to go all the way down here. That's okay. And then this one needs to go one further down. That's good because they're in the right sort of orientation to do that. This one needs to come up here to this pin. That's cool, I can do that. So if you right click on the ground plane edge and select orphans in the menu, it will fill that blank area in and it won't be connected to anything, but at least there'll be a copper layer there. What? So select orphans in the menu. I don't know if I'm in the right. Is there a tool for that? On the edge, I see. I don't really see. Never mind, we can look at it later. I'm not overly worried. The fabrication house can worry about how much copper they etch away. I suppose it does help with heat sinking if it were an issue. Now we've got 2 here, and I'm going to have to come down on the ground plane, not the ground plane, on the bottom, and bring these across, then jump onto the top here. I'm going to give myself as much space as I can. Hopefully that didn't screw up any grounds, because that's what frickin' happens all the time. It's kind of ugly, but I'm going to go with it. You'll have noticed I'm not really a big fan of right angles with traces, and that's a bit of a throwback to when I used to get them routed at work. So they used to use a CNC machine to route single and double-sided boards for me, and a right angle trace with a router would cut on the inside quite, not necessarily sharply, but if you're going to use small traces, it wouldn't give you an exact right angle, and the small traces would be etched a bit further away on the inside of that angle, which meant current handling capacity was less. So that's why, but you know, that's years ago, and they've got a different machine these days. My trip to Denmark was great, thank you. I really enjoyed it. It was a lot of fun. I'd love to go back, especially if the weather gets nicer. I think I'd like to go in the summer at some point, or in the spring. But it'll be a while before I head back again, I think. I want to go to maybe Nepal or Thailand, and I'd also like to go to Switzerland as well. So those are probably the next trips. Satonic says, "Hey David, how hard is it to get into PCB designing? I've used usual circuit boards and soldering for some other projects, but I'd like to get into this." It is not hard. It will just take you a little while. So start by designing something really simple, something through hole. So something with dip circuitry is really easy to design. Try and do a single layered board first. That's my advice, because you learn a lot being able to jump around single layered boards. So it's an easy one to do. If you're going to use through hole resistors, it's practically like using a via. It's brilliant. So you can jump over components and over traces with those. So learn how to do a single sided board first, then look at designing with two layer boards, which will shrink your designs down massively. But pick up Eagle. It's a great bit of software that is free. There's a free version of Altium as well, which is another software designing package you can use. And I'd also recommend trying that. So give it a go if you can. Where is this going? So this is on the top side of the board. I can bring this across. There are no grounds here, so we're all right. Let's jump to the bottom side, and then we're going to have to jump back to the top now. And let's try and keep this lovely little pattern going. Oh, come on now. I mean, it's practically there. I'm going for that. But there's so many tutorials available for Eagle, it would be silly not to try that one first. Oh no, there's another one. Where's this going now? Oh, it's only going to power. Hang on a minute. You're going to... Okay. Where am I going to send you? Well, it certainly doesn't need to be that trace there. It can go to there. Which means what exactly? I need to get over there to, that's 5 volts right there. Ugh. Let's move this damn thing out of the way. So we've got, okay, hang on a minute. Let's think about this first. I'd really rather go over here for the 5 volts. I'd rather have a bus line going across here, but we've got this frickin' trace for the battery going all the way over there, and I'm not even sure. Oh, that's the battery. This is the programming pin. Do you know what? I'm tempted to take the battery monitor out, but I did want to add some circuitry so it would turn itself off. Darn. It would turn itself off if it reached a certain battery voltage. I don't know. I don't know what's a good idea to do there. But let's put it all in. If I just monitor the voltage, it doesn't really matter, does it? So I'm going to have to go on to... No, I'm all on the top layer okay. It seems like really far to go to get 5 volts, doesn't it? I mean, I can do a bottom layer of the board, bit here, back to the top layer, and then get there. Should we do that? I mean, at least it'll be done then, won't it? Oh, actually, I can just go bottom to this chip here, I guess. And then this one will want to go down here as well. We'll switch to the top, connect it up, boom. Is that everything routed? Oh, look at that. Ground issues. It's always a ground issue. Right, what is the problem here? So what we've got, why isn't that connected? Oh, screw it. You know what? I was just being fancy by putting that on the bottom of the board anyway. It can just come over here. I don't mind. There is nothing there, so it can just sit about there, can't it? That's fine. It's just a capacitor for this thing. In all honesty, I've never really had to worry about a capacitor with a 7.4HC595 anyway, so I'm just going to throw it there, screw it. It's close enough to the power pin. Well, the power pin technically is up there, so, but I can't fit it there. So that's it. Is that it? Is there anything else? Oh no, look. There are more ground things here. Right, we'll have to do some kind of thing. So if I just put, I don't want to put a wire underneath this crystal. So I can put one there, can't I? Let's do that. Okay, I might have called that GNS by mistake. What? There we go. For switching it on and off, I was just going to go with a transistor approach and a button that briefly connects power to the transistor, which turns on the circuit, and then the microcontroller has a wire going to that transistor, or a trace going to the transistor, to keep the circuit on. So the moment the microcontroller starts up, it puts the pin high, and it will stay on. The button won't then switch off the circuit. You need 2 buttons to do that, one that would ground out that thing. But that's all I was going to do, just a momentary switch, and just have a transistor that would turn the circuit on. The circuit's going to draw at max, I imagine, under 200 milliamps, 150 probably. So it's not going to be a lot. So I can just use a one of these small transistors, or I've got some SOT23 MOSFETs as well I could use. So R21 is not routed. Thank you very much. It's a good spot. All right, I'm constantly on the lookout to see whether ground has been ruined every time I route something. Now, what else isn't routed? Well, we've got all of these, which looks like a little bit of a minefield. However, I worked out a perfect way of doing it. And I think we can go that close to the chips as well, which is nice. Let's just check. So if I rat's nest that, and then this is the design rules thing. So you load up your design rules thing. In my documents, in Eagle. Let's open up PCBs.io. Apply and check, and we have some clearance issues over here, look. So that is not going to work. Okay, what am I going to do about that? Can I move them slightly? I think my grid's going to be too much, so let's change my grid to 1 mil. And because I don't like the way they've come out there, so let's just do those again. And we'll check again. I mean, that's a bit close anyway. I'm not sure I'm happy with that, but I think we're going to have to rethink those. I think they're going to have to come out here. Yeah, I think they will. But that's fine. So I'll drop one down here. Oh shit, that's a ground, isn't it? Fuck. Oh, actually, it'll be connected because this will come out, so that's fine. Okay. Let's put my grid back to the way I want it. Connect it up. Now if I rat's nest, that ground is still connected in your faces. I know you didn't believe in me, but there it is. Now I'm gonna have to give myself a little bit more space over here to, oh sugars, I didn't want to do that. Let's leave that as it is, and let's remove that. Where's that going? Oh, it's only over there. Okay, that's cool. And we're going to do a little bit more of an extreme angle there, just so that I can draw this out here and then drop onto the bottom layer. And then remove stuff then. Let's see. Oh. Piss off, computer, telling me that things are wrong. Huh? Are those two just connected together? Oh, of course they are, yeah. So they're connected together, and then No. What's gone on here? Oh, I see. And then we've got another trace that's just there. Oh, yeah, I remember. I remember. They're not overlapping traces. This is on... Although that is overlapping. I guess not. I guess that's fine. Yeah, I was a bit confused. I'm tired, I think, so I'm just staring at stuff now. So we can go across the top layer here, and then we're good. And then I think that's everything apart from doing the LEDs, which is the really easy bit. Hang on a minute. Can you see what I can see? There is a trace from this LED to all the way over here. I'll tell you what, we're just going to do this. Now, how can I attach that? Let's think about that after we've done everything else. So the Max 16054, let's have a quick look at it, shall we? One 6054. Oh yeah, I don't like turning off the layers because then I can't really see what's coming. So on-off controller, this sounds awesome. You know, I made an on-off switch that Dave Jones had designed. I sort of altered it a little bit for my needs, but it was very good. What packages do they come in? Maxim actually don't mind sending me samples. So what you've got, you need just the chip and a resistor. What's the micro P? So this is what I'm looking at. This is the Max 16054. Let's see, in order it should tell me. Oh, it doesn't say you can sample them. It usually says there, I think. Well, there might be a separate section. So TSOT 6. Let's have a look at that. Oh, what did that just do? Oh, it just loaded up the page. Okay, so let's have a look at the data sheet. Are you going to load up that data sheet? There we go. Okay, so it's just a thin SOT 23, so that's their old T-SOT. Yeah, of course, idiot. So what's this? What's that there? The what does that say? Micro P. So you've got an LDO. Oh, okay. So I see that does in VCC out to the enable of an LDO. So you need something that switches the power here, but you could be a transistor or a MOSFET. Is that Down to page 7, okay. All right, I'll go down. Typical operating circuits. Okay, so out is just out. Well, that's useful. Let's see if we can find some specs. Current. I'm looking for current. I mean, I imagine it's going to do what I want. How does this not tell me current? The first graph. Supply current. Output logic level. I mean, those graphs seem to suggest that actually the current passes through the device, right? So is there a maximum current that you can put through? On page 7, the first graph. Okay. So this one, oh, with the MOSFET here. But out can supply current as well, according to this schematic here. But it doesn't say that. I guess maybe I'm just reading this wrong. Maybe it's only an on-off signal switch in that diagram. Well, this is a bit of a weird one, isn't it? This 2 buttons to turn it on. So you've got you have to push both buttons. Why did they feel they needed to put that in there? That seems really weird. Yeah, VCC through the MOSFET feeds the circuit. I get that. I'm just wondering what this one is here. So what's out? Not ordinary. So this indicates voltage and current out, I assume. Do you know what I could do? I could read the description of the pins, or I could read the whole document, really. I'll tell you what, this is time for this. Oh, it's just an active high, I see. So it doesn't actually run any kind of real current or anything through it. It's just an on-off. Well, that's a good shout. I might pick some of those up. Dude, you're like filling up the chat. It's really hard for me to keep up. All right, we'll route the rest of this. I'm going to keep going for another half an hour, and then I think it will be pretty much bedtime. Look at this. I love how don't do it, computer. How nicely you can get these matrices. Let's call them that. How you can get them to sort of root out. I love the uniformity of it. I mean, I'm going to ruin it shortly by routing those two. I mean, it's going to destroy the ground plane in a minute. My favourite thing to do. Oh, well, that looks ugly, doesn't it? That's my 6mm grid that I changed after I placed these LEDs. So it means they're not sat perfectly in the grid where they should be. So sometimes it won't snap properly. Like that one's perfect, but the next one won't be. You know, after I've routed these boards, any boards that I make, and it often happens, I make an awful lot. There are loads in, you can see here, I've got a lot of boards that I've made and never ever printed. And that is because I just quite like making boards. I quite like the challenge. It's sort of like a puzzle. So I enjoy routing the boards, figuring out the circuit. Even if it's just a challenge like, wow, I fancy figuring out how to route this sort of complex board onto the next one, and then I'll just leave it because I won't actually want to make it. I've already solved the problem in my head or in the schematic, so let's try and get it looking roughly like that one there. Oh, there you go. Sorry, yeah, I assumed that chip was, well, I assumed it sort of just had a MOSFET in it. I thought it was, I thought it did everything and only required a resistor and a switch, which would be lovely if that was the case. Maybe they do make some, it's possible. It'd certainly be useful. I think a lot of people appreciate something like that. But as it is, it does enough. I suppose you don't want a MOSFET in there because you don't know the requirements of the person using the switching IC. So it becomes a bit more useful for people, I guess. I don't even know how many people are watching, if anyone. It doesn't really matter if you are watching or not watching and not commenting, it doesn't bother me. I was just going to do this anyway, so I thought I might as well stream it. It just means I'm not picking my nose while doing this, because I'm on camera. That's essentially it. I got a new keyboard today. It came from a company called I bought a keyboard from them before. It was a little 2.4 gigahertz wireless thing. And so I've got another one, which is another one of those wireless ones, but this one's a bit nicer. It is, it's got, oh, look at that. That's wrong, isn't it? It has a multi-touch thing on it, and it's a full keyboard as well. So I am looking forward to using that, and I don't think it's very expensive, so I might show you guys. I'm not sure, we'll see. But the idea is I'm doing some Raspberry Pi stuff at the moment, and I don't want to be surrounded by my full computer, so I want to just be able to do it on its own. And I'll probably plug it into the telly or something like that, I imagine. I really love going into the terminal on a Raspberry Pi. It honestly makes me feel like a hacker or something. When I was a kid and I used to play around in DOS and I'd play around on the command line, I honestly thought I was a hacker. And then, I don't know if any of you have played NetHack, which is like a computer game from a long time ago, but you can play it online in a browser. Is it NetHack? I think it is. It is brilliant. I was kind of hoping to get this board before Christmas. I don't think that's going to happen. What's the date today? It's the 30th? No, the 29th, so it's the 30th in a half an hour. I was hoping to get it before Christmas, but I don't really think they can turn it around in that length of time, so we might have to wait until January sometime to get this. It's not necessarily a problem. Oh, don't do this to me. You're in the wrong place. Come on, there will do. There we go. But I did want to sort of play around with the programming and stuff while I've got some time off work. But I've got plenty of other projects to do, I think. Stop. I've gone too close. Let's do that again. Okay, we'll go up a little bit higher. You can use one low or high current MOSFET with that design. You just connect the momentary switch to it to trigger on and off, and then use the two out pins to control things. Kiori22, I'm going to say that's what your name is. Dip trace. I don't think I know what dip trace is. So if you want to just explain what it is, that'd be great. Hello, Ronan. No, I'm not going to be etching the board in the sink. It's definitely going off to a company to sort it out for me. PCBs.io is the company that I am enjoying at the moment. I've got a couple of boards on order from them. Will be arriving at some point. I don't know when. You never really know with a fab house when it's going to happen. The cheaper ones, that is, because what they do is they panelize all of your boards. They don't do a private run for you or anything, and they just wait until they've got enough orders to fill a board. And it might be that someone's sent into really awkward shapes, so they'll just wait until they've got a small board to put around it. So I don't know when it's going to arrive. One of them's been panelized, and I'm waiting on the other to be panelized, so I'm not sure when they're going to arrive. Oh, we are almost there. This is... Oh, what the hell is this? All right, I know what that is. Sorry. I saw these traces here, and I thought, what the devil have I forgotten to route? Oh, these don't look exactly the same. It's going to set me off. Oh well. You won't notice when the solder mask's over them, hopefully. Because I get quite a number of boards sent to me when I get them done at PCBs.io or OSH Park, I'm going to give one of these away and hope that someone fancies making it themselves. I mean, that is if it works, obviously. Okay, I'll take a look at Dip Trace then. Is it free or is it a paid for bit of software? I mean, Eagle itself isn't actually free. If you want to use it commercially, you have to pay a license, but the free version is there for non-commercial use. No, I really do think LED matrices are a little bit like magic. Oh, Mayday, look at this. Got some stuff in the way, just avoided it. Right, I'm just going to grab something. I don't know if have I got two batteries here? I've definitely got one. Is that a legit battery? It looks a bit horrible, but I'm just going to grab it. Oh yeah, I do. Does this thing work? I don't see my thing now. There we go. Well, I've got a board that I got OSH parked. Let's call it that. You're not even connected to the mic anymore. Maybe you can hear me better now. So this was a board from OSH Park, and it was the last LED matrix I did, and it's not working. Oh, the batteries are just I don't know if you can see that. It's a bit bright in here, really. So this was a little LED matrix I made. Well, that's reset. I wanted to change the mode. That's better, isn't it? So you might have noticed there I didn't debounce this button. So yeah, I'm struggling to change the mode. There we go. So I love an LED matrix. So I made this little one, which just does a few little patterns. It could do a lot more, but I didn't do much with it. So it has an AT Mega 328 on there. It has two 74HC595, so it's an 8x8 matrix. So it's got 64 LEDs, which is an awful lot, more than this board's going to have. And it was designed for a different purpose, really. So it was designed not to tell the time or anything like that. It's just designed to be a weirdish curio board, I guess. And I only ever put together one of those. I didn't put together the two that I got printed. Right, that's that awkward one that's gonna piss me off in a minute, I think. So this is really easy, this bit here. So after someone told me in the last stream that you could just press the middle mouse button to change which layer you're on, I mean, this just goes by very quickly. And then the last bit is just to connect that up there. Now these resistors go off to the TLC 5940, so they're not connected yet, which is not a problem at all. They can connect now, like that. Super simple. Let's just have a look at the chat. So PCBs that I should be paying for the advertising. You know, they're doing more than enough for everybody just by having really cheap PCBs, honestly. So dip trace is free. That's cool. 300 pin freeware. I'm not quite sure what that means. Where's across the pond? Which pond? I'll happily send one to you if you want one and you want to put it together. Then that will not be a problem at all. YouTube, I get a little bit of money from YouTube every month, so that's what I buy parts with occasionally, and sometimes I'll save it up to do other things, and I'm more than happy to use a bit of it to send a board to you. I will even, if I have any spare bits, include some of the components that I've used, because I'll send you that crystal. You seem to only have like super cool resonators, so I can do that. And I've got some 0603 LEDs I could send you as well. You'd have to use the color I sent though, so you might want to find a different one. I can send something to the USA, that's not a problem. Look at that. That is going to really trigger me. Look at those two. Let's undo those. We'll keep that one there. Jeez. I think designing PCBs is the only part in my life where I have any of, what is that thing called when people are like a stickler for details? OCD type behavior. Designing PCBs is the only time I have that. I like uniformity. I like this kind of spacing between lines. I like everything to look like just so really. And I think, you know, that it's probably quite a good thing for circuits to be just so. If it's uniform, you can trace out problems more easily, I think. But it also means if you've made a mistake, then you will have crumbs. Where am I going? You will have uniform issues across the board because you will have made the same mistake everywhere, most likely. Oops, that's tiredness kicking in there. I can send you the gerbil files, that is fine. We'll wait till it's finished and it works. I think there's probably going to be some bits I'm going to have to add to this board really. I might just put a physical switch on it. I mean, we're only talking, what, 200 milliamps at maximum, so I'm easily going to just be able to put a little switch on there, I think. I've got some SMD switches I can use. That is in the wrong place. There we go. And they will probably cope with 200 milliamps. I think they're rated for like 25 volts, so I think that should be okay. But otherwise, I will see if I can pick up one of those little Maxim things because they sound cool. They're not quite uniform, but we're going to leave it. In the interest of finishing this off this stream, as opposed to last stream where I had a terrible board done and I was quite ashamed of it the next day when I went to look at it, and I immediately started redesigning it. Incidentally, I've come up with a new design for another clock as well, based on NeoPixels. Whoa, look at that. Who's forgotten to do that? I found out that you can get some warm white NeoPixel type chips. They're not NeoPixels themselves, they're different. Who forgot to do this? Well, that won't do. They're like NeoPixels, but they're not WS2812B. They are SK something. But I'll order some and we can have a look at it then. But I'd like to make a nice looking large clock that's semi 3D printed with maybe some see-through parts where the LEDs can shine through and you'll be able to see. It'll give you an indication of the time. I'm going to use the wood filament, I think, for the housing of it because I think that'll look nice. The warm white LEDs will be the indicator for the hours, and then I'll use some color LEDs to indicate the minutes as they pass. So you'd have 12 warm white sections, which probably have 3 LEDs in each, and then for each I'm going to segment it. So I'll create one board that I'll put around the whole thing, and I'll segment that so you have 5-minute LEDs and then 3 hour LEDs. So each segment will be a 5-minute segment. Is that right? Yeah, roughly, I think. The idea is not completely fleshed out. I need to draw it first, I think. Look at that trace, that's going to be a bugger. I realise that's not in the middle. Stop being a douche. No. There we go. Oh no, what? Is that going to create a wire for me? No, it fucking won't. Fine. Start from the beginning. Oh, do you know what? I'm so tempted just to cheat here. I'm just going to cheat, go over the bloody trees. Oh, for fuck's sake. I just swore then, I do apologise. How cleanly can I just move those up slightly? Not cleanly at all. So I'm going to have to do those ones again because they're too close. That's okay though. I don't mind redoing stuff. Okay, that'll do. Right. This looks nice, so that's going to work, isn't it? Okay. Oh, look at that fucking thing over there. Jeez. If you hear swearing, I think it's probably your TV's too loud in the background, so that you're probably getting something from some American TV show, because this is a kid-friendly stream. Well, it's probably not. God, how much more is there? Right, this is looking promising now. This is like the last hurdle. There's only one more thing I need to do. Oh, for heaven's sake. One more thing I need to do after this, and that is just to break out the TX and the RX pins on the microcontroller, and then we are golden, hopefully. Oh, there's an awful lot of stuff over here. Where did it all come from? If someone tells me about a shortcut to get rid of all of those, then I'm going to turn off the stream. I don't want to know if there is one. There we go, right. Design rule check again. Is there anything? What do we, why is there an overlap there? Oh yeah. Okay. Well, I don't know who put that there. That certainly wasn't me. Who on earth would have done that? So it's because... So that can just go straight down there, can't it, I think? Yeah, it can. This one can't though. No. That one can go there. Okay, just calm down, calm down. It's all good. Everything is fine. We're in a safe place. Okay, we're almost done. I haven't used the TLC5940, the little PWM chip I'm using, for a long time. I do hope it is as easy as I remember. But if it is difficult, I'm just going to use somebody's library and credit them, of course. One thing I don't mind is working with shift registers. You can write your own code for that really, really easily. Right, that should be... Yes! Okay, that is everything. Is it? No. No, it's not. We've got this absolute git over here, look. Luckily, we can go on the bottom layer with this one and fire it straight across. Look at that. Hopefully it doesn't mess up every ground that I've got. I don't see any more yellow lines anywhere. Oh yeah, I do. There's one. Any more? No, I think... Is that? No. That is it, ladies and gentlemen. We are almost done. Let's just double check that design rules thing because we've just bypassed a load of... Look. What do you mean drill distance? And overlap. When did I put that there? Oh yeah. Like just now. Fuck. Bloody hell. Right, how are we going to get around this? Oh, rubbish. I'm just going to come from the other side. Did you see it had two vias there layered on top of each other? That's annoying. All right, I've gotten rid of that one for now, just because I'm going to use the bottom layer of the board to come down here. And we're going to cheat and go this way instead. And then this just needs to be connected up. Boom. Now, I have one question for you all. If you know how to use Eagle. Oh, maybe this, well, the electrical rule check will just give me some crap about my schematic. Missing junction in net. Ah, not connected. That missing junction in net thing is very annoying. It definitely doesn't mean they're not connected, because all of those resistors are connected. Power pin connected to 5 volts. Yes, it is. Not sure if AVCC should be, but well, I'll have a look. No value, no value, no value. Does anyone know if there's any way to find out what's not connected on here? Well, even if not, it's fine. Let's figure out where the RX and TX are, because I can't remember. So let's look at 80 mega 328 pin out. And I think that's the best one, isn't it? That's the best one I've looked at least. So mainly because in the schematic here we don't have nice descriptive values. We have PDO, PBO. Now if you're familiar with these boards in a different format or not using the Arduino IDE, then it might confuse you, as it does me. So it's on PDO and PD1, which are just there. Which way round were they? PDO is RX. RX. Oh. Sorry, I'm getting tired now. I think I'm going to call it a night because it's 12 o'clock. There we go. Okay. Should I change that to a 5 pin and shift some stuff around? I think that's probably for the best. So replace, probably going to ruin everything now, you watch. Pinhead, no, 6 pin. Since there are different pins, they will be replaced by, God, no, that's okay. Oh, okay. Yikes. I mean, it fits. It fits just. Let's pop that there. And let's get rid of that. And we'll put that back. This one can change now. And And now we're just going to move these around. That's not a lot of clearance there, but we'll just do these pins last. So that can stay there, and this can come over here, I guess. No, because I want to be able to write on the board what those programming headers do. So let's get rid of that, and you can jump around here. In fact, that'll be perfect. I can put some text beneath it just saying it's charging. There we go, and that's removed one via. Oh no, it hasn't. I've got to put another one in. There we go. Everything's okay. Now, here is the really annoying part. I'm about to connect these to TX and RX. That said TR, didn't it? Yep, connect that up. Name, RX, connect that. And then we'll stick the name down there. Okay. The ICS, see, I don't know a lot about programming chips, honestly. I know a lot about, not programming, but you know, like programming these bare chips with a bootloader or just burning a program straight to it. I know the way that I've done it in the past, which is by putting TXRX and breaking out the pins I need to burn the bootloader, but I don't know if you can just burn your program straight to the chip and not worry. Oh, flip, look where they are. Shitbags. All right, maybe I'm better off just putting the pin headers down here, just two, and then bringing those out there. And do you know what, I might do that. I might. I might just do that. What's this? Oh, look, it did cause an issue. Unconnected grounds. Right, we're undoing everything we've just done. Don't know if you can hear me pressing the Z key. There we go, undone. Ground is reconnected. We're back on 4 pins here, that's fine. We're going to go for a single 2-pin header. And I'm just going to stick it there. Not going to do anything fancy, we're just going to do that. And then it should appear on my thing here. Excellent. And I'm going to try and fit it somewhere. I don't need them that big, really. I mean, they would work better there. This is a bit tough, isn't it? It's like doing puzzles. I love puzzles, but how close can I get with that one? I need a bit more space. Holy crap. Didn't want to do that. There we go. Okay. I tell you what, I could move this. What is that? R7. Let's see what R7 is. That's the battery thing. Okay. Let's move that. So we've got, so if that's on that side, okay, let's take that out. I can fit it there. Do you know, that's probably the best scenario I can see. Whoa, not that. That there. Okay. Oops. Didn't need to do that. Oh, look, that's beautiful. We can definitely do this. So if we take it from the top, oh look, sneak it through that little gap there maybe. And then up to there, there, there. Oh, for heaven's sake. Why do you have to destroy the entire ground plane? I mean, look at it. Okay, let's undo it and just see how much copper did I actually take away there. Oh, not that much. Okay, that's fine. I'm all right with that. Is there a redo? Yeah, Control Y. Oops. Control Y doesn't work. Just so you know, that doesn't work. Right, I didn't need that ground plane anyway, it's fine. Now we've got 2 pins over here. Let's flip that round and move our trace. Do you know, I could sneak that through there, couldn't I? But I don't think I need to. Let's see. So if I jump... Shit. If I jump to the bottom layer, I can get over there, can't I? No. Because that's on the bottom layer, isn't it? What if I come around here? Nope. Because that's still on the bottom layer. What if I come around there? Then yes, I can. Except we've got this trace here, which we can sort. That's fine. Let's do that. And then A DTR capacitor to ground on the reset line. Yeah, I've forgotten about that. I think. I'll have a look in a minute and see if I did it. Hmm. Look at that, it's not ruined every single ground on there yet. So that's good. Let's just run that design rules check thing, make sure I haven't screwed everything up. Oh, for heaven's sake. Of course I have. Where does that one even go? Oh yeah. That should be all right. Clearance. God, that was ages ago. Okay. I could not queue up one. Oh, that's the auto router that I almost did. Whoa! One more thing left to do. And that's to connect. I don't know what that is. Let's connect this to over there. What does that go to? Shit. Something important, I think. How am I going to do that? So we've got bottom plane wires traces there. And we've got top there, so I can't jump over that section. I could come down here. Flipping hell, this is. What am I going to do about that? Oh, hey Emily, how you doing? I'm tired building a circuit, and I think I might end up calling it a night. I can't even talk now. Might end up calling it a night now because I'm tired, and there's this one trace that I need to get over here, which means passing over these two top layer traces and two bottom layer traces, or figuring out a way that I can not have to do that. I can't bring the bottom layer traces over here, and I can't bring the top layer ones further down, but I can do this. There's nothing underneath these, so they can move. Oh, I'm not soldering wires manually. That's shoddy work, that is. I did that on my last matrix and I felt bad for it. Not for it, for myself, because I should have worked harder to stop it needing those. I don't think it does need them, that's the thing. I think I'm going to be able to get away with it. I just need to try harder, I think. So that can go just there. Are those just capacitors? I think they might be. I can't really remember what they are. So let's take that trace out. And that one. And let's see our board outline now. So, darn. I mean, it gives me some more room, but only really on the top layer, and I still need to bring that one across. This is the SDA and SCL, isn't it? Okay, right. Just destroy every ground there is, it's fine. Can I go anywhere with this? It's not small enough. The traces aren't small enough to go through pins. Ugh. I can come down here. I could jump over that. And then we've only got one there. Hello, that might work. Let's see. Right, we're going to jump here. This is so... It's just dirty. Let's leave it like that for now. Let's take that out. Let's see where our clearance is. I hate you. We'll connect this one back up. I mean, look, it's only a short distance, but I want to take it from over here, ideally. So, we've got a trace there that I need to get over, but I can't. Oh, look, that might work. Oh, whoops. Undo that. Oh, it's gone, right. So, the plan is auto router not classy enough? It's not quite classy enough for me, no. The plan is I'm going to take this wire. In fact, let's just do it from there. We're going to go, this trace is coming down here. Now this seems like a really crazy... Right, and then I'm going to sneak in a little via there, I think. And then, I don't know if I can do this. No. Shit. How am I going to do that? I just need to get over this bloody thing here. And then look, we'd be fine. All right, let's leave ourselves with a different problem rather than the same one that I'm not really doing very well at. So now we've got this problem. That's the only unconnected thing now. So where can we go with that? Oh, look at that. I can wire it the hell up here. All right, let's do that. So let's take this out again. We'll come a bit further down this time. We'll do that. We're going to wire this there and jump across. Boom! That is done. And that is everything everything I wanted. I've got my RX and TX, I've got my bootloader programming lines over here and resets over here. Someone mentioned something about capacitor, but honestly it's too late at night now to even think about it. It's now almost 12:30, so I am calling the stream. So thank you very much for coming, everyone. It's probably going to be the last stream for a little while. Oh, fuck off. Sorry. Did not mean to swear, but I just noticed. Oh! An unconnected ground. Simple fix though. Hopefully. Let's just flip this thing around, shall we? Then their grounds will connect. Except now they won't, because it needs to connect to that one. Oh, that's because it's still connected to that. Because it's a capacitor for smoothing out any voltage spikes, which there blooming well will be, because it's right. Let's try that, because it's going to run off a DC to DC converter. Flip. And it will be noisy as all hell. So let's see if I can get away with that. I can. Now this is going to get rid of the grounds again, isn't it? Darn it. But not if I use some fancy technique. Like that. Done. Oh. Right, one more wire is going down right in the middle there. And then it's definitely it. Boom, fixed. All right, thank you very much, guys. I will see you the next time I do this, which won't be for a while. But I will be doing a video soon on some various little projects that I've got going on. Anyway, good night all.